Alright, let's get started here with 7.7 inverse relations and functions. So, lesson preview, we're going to learn to find the inverse of a relation or a function, and so those are our two vocab phrases: inverse relation, inverse functions, and these are very closely tied together but slightly different than one another. So we'll go through the differences in a relation and a function here, but before we do that, let's get our skills check going. We need to graph on a single coordinate plane. Quick reminder how we are graphing. Here's number one. And remember, we can do slope intercept. So for this first line here, we're going to go down 6. That's our intercept, -6. 1, 2, 3, 4, 5, 6. Make a dot. And from there, we'll go up 1 over 1. And connect those. And then the other one says go up 6. Our intercept is +6. Make a dot, and from there we'll go up 1 over 1 as well. And we'll connect those, put arrows on the end, meaning they go forever. And those are parallel lines because their slopes are the same, 1 and 1. Okay? So your job is to graph the rest of these for 2. And just a heads up on these fractions, one thing that you can do to rewrite this is 1/2 x minus 7 over 2 is 3.5. Okay, so you might want to rewrite them like that to better help you out with the slope and the intercept. All right, so take a few minutes to get those graphs going, revisit how to graph lines on a plane, and try not to do them all on a single coordinate plane. Okay, 6 different graphs is what we're looking for on this. All right, and when you're ready, press play and we'll get going again with 7.7. Alright, so inverse of a function. So, if a relationship maps element A, alright, so something from the beginning, from the left side, and turns it into element B, so 1.2 turns into 1, okay, the inverse relation undoes that. Okay, so 1 would turn back into 1.2 in the inverse. Okay, so this is a relationship between two sets of numbers. 1.4 turns into 1. The inverse is going to undo that. 1 back to 1.4. Same for 1.6. Turns into 2. The inverse turns 2 back into 1.6. All right, so if A comma B is an ordered pair of the relation, then B comma A is the ordered pair of its inverse. So look what's happening here. We're flipping our x's and our y's when we're doing inverses, right? So x becomes y in our ordered pairs. All right, so let's take a look here. Find the inverse of relation S. So we're going to flip our x's and our y's. So in the first pairing, it's -1, 1. Now it's going to be 1, -1. For second pairing is 0, 2. Now it's 2, 0. 1 and 3 becomes 3, 1. 1, 4 becomes 4, 1. All right, we can do the same thing graphically. This point right here is 1, -1. So we're going to make it instead -1, 1. Right? This point right here is 2, 0. So we're going to make it 0, 2. The fourth point, this one right here, is 3, 1. So now we need to make it 1, 3. And the last one is 4, 1. So we need to make that 1, 4. All right? So your skills check on this one is to describe how the line y equals x is related to the graph of S and its inverse. If you look back at here, the line y equals x, how does that relate to inverses? All right? And then in example 1, so I posted it here again, is relation S a function? All right? Now remember, a function has to pass the vertical line test. Okay? Every input has to have one exact output. All right? So is relation S that, does it pass those rules? Is it a function? And then also, is the inverse a function if we flip it around? All right? So think about that. And when you're ready, we're moving on to example 2. All right, find the inverse of y equals x squared plus 3. So we found from the last relationship that we're going to switch the x's and the y's. So that's what we're going to do here if we don't have pairs but just have the actual equation. So instead of writing y equals x squared, we're going to write x equals y squared. We're taking the x and the y and we're swapping places. And then our job is to get y all by itself again. So we're going to subtract 3. X minus 3 equals y squared. How do we get rid of a squared? We're going to square root both sides. So the square root of x minus 3 is equal to y. All right? That's the inverse of the original function, y equals x squared plus 3. All right, so think about this. Does y equals x squared plus 3 define a function? And then is its inverse a function? Right? Think about again what a function is. Every input has one output. Find the inverse of this equation here is the inverse of function. All right, so again, switch your x's and your y's, get the inverse. All right, example 3, y equals x squared plus 3, and its inverse is y equals plus or minus the square root of x minus 3, and we're going to graph this. So, to graph a parabola, remember we go up 3, 1, 2, 3, right? And then from there, we would go up 1 over 1 on both sides, and then over 2 up 4. 1, 2, 3, 4. And we're looking like that. And there's our parabola. All right. And then if we turned it into its inverse, y equals plus or minus x minus 3. All right. So let's take a look at this. What if we did 0 as our x? Can we do the square root of 0 minus 3? No, we cannot. All right. What would be the first x value we could use? 3. Because 3 minus 3 gets us 0. And the square root of 0 is 0. So 3 comma 0 is going to be where we start. All right, let's see what happens if we use 4. 4 minus, oops, not 4 minus 1. 4 minus 3 gets us 1. The square root of 1 is still 1. So 4 comma 1. Okay, but remember it's plus or minus, so it can be also negative 1. Okay, and so we've got enough to get our general shape. That is going to be the graph of the plus or minus square root function. All right, so we've graphed them both on the same coordinate plane, and you've seen already that the line y equals x should be the mirror over which we're folding these. All right, so your turn. See if you can do that with y equals 3x minus 10. See if you can graph both that and its inverse. Okay, let's take a look at what we're saying here. The inverse of function f is denoted by f negative 1, right? And we read that, we don't say f negative 1, we say the inverse of f. But we're going to write this, f with a negative 1 up at the top, all right? And you'll see that if you look on your graphing calculators, you'll see x to the negative 1, right? That's your inverse function key, all right? So the inverse of f is written as f with a negative 1, all right? So it might be a relation that is not a function, so that we have to be careful with this. So consider this function, f of x equals the square root of x plus 1. Let's find the domain and the range. All right, so the domain, we already remembered that x plus 1, the stuff under the square root, needs to be bigger than or equal to 0. It has to be positive. Otherwise, we're taking square roots of negatives, and that gets us imaginary numbers. We don't want that. We want real numbers. So we're going to move this around, subtract 1. X has got to be greater than or equal to negative 1. All right, that's our domain. Okay? And then the range of this is going to be on this one. If we do the square root, and we just have the positive here, we don't have the plus or the minus. When we do the square root, I'm going to show you what the graph looks like. The graph would look like this going up, but not the bottom side, because we don't have the minus. We just only have the positive answers. Okay? That's going to be y is greater than or equal to 0. It's only positive. It's only going up. So that's our range. All right, so let's find our inverse here. So remember, we're going to flip our variables. Instead of this, remember, is our y. So now we're going to say x equals the square root of y plus 1. We need to get y by itself. So we'll square both sides. X squared equals y plus 1. Subtract the 1. X squared minus 1 equals y. All right? So if we take a look at that, I'm just going to graph it real quickly over here. We would go down 1, Okay, and then we would graph this. Oh, I made a mistake there. Apologize. The square root is going to start over here and go like that. And then our square root is going to go up like that. Okay? Nope, made a mistake there again. I am all over the place here. That's what happens when you're going too fast. The square root is going to start to the left here and go like that. Okay? And then our x squared, our parabola, is going to start low and go up like that. Okay, there's the line y equals x that will bisect. All right, so we have this. Let's find the domain and the range of the inverse here. All right, so the domain and the range. Now you'll notice I've only drawn it on this side because the domain and the range must flip also. So if we looked at the original domain and range of the function, when you do the inverse, you need to flip them around as well. So the domain is going to be what we had for the range before. Okay? X has got to be greater than or equal to 0. That's why I didn't draw the parabola over here on this side. Okay? Because we only want the positive x. And then the range, okay, we're going to have here, what do we have? The domain of the other one, y is greater than or equal to -1. Okay? All right, on this one, is the inverse a function? Go ahead and explain this. As long as we keep this domain, it is going to be a function. Remember, function passes a vertical line test. All right, so the inverse absolutely is a function. It passes the vertical line test. All right, a lot going on there. We might have to discuss this in depth in class, but see if you can extend that for yourself and think about a, b, c, d, and e for this function here, 10 minus 3x. All right, let's take a look at a word problem here. D equals r squared over 24 is a model for the distance in feet that a car with locked brakes skids in coming to a complete stop. All right, so r is our speed in miles per hour. So the more speed we have, the faster we're going, the farther we're going to skid if we throw the brakes on and have to come to a complete stop immediately. All right, let's find the inverse of the function first. So first things first, we're going to switch the d and the r. So r equals d squared over 24. And our job is to get d back by itself, where it was originally. So first step, let's times both sides by 24. So 24r equals d squared. And let's go ahead and square root both sides. So we get the square root of 24r equal to d. All right. Use the inverse to estimate the speed of a car that made skid marks 114 feet long. All right. So now we can say that the distance, find the speed. Yes. So we want to find r on this one. And you know, that's not as helpful. I'm going to just start with the original up here. R equals, no, I'm going to stick with this. Okay. The inverse here, d equals the square root of 24. R, use the inverse to estimate the speed of a car that made skid marks 114 feet long. Square root of 24, R equals d, and the skid marks were 114 feet long. Okay, so on this one, let's go ahead and square both sides. We're going to need to square 114. Going to grab my calculator. 114 squared is 12,996. And then we're going to need to divide by 24. So 541 miles per hour. That seems awfully fast. Hold on, I must have made a mistake here. Let me pause this for a second and check. 1 second. Okay, I took a look at the book here and in the textbook, and I don't really love what the textbook is telling you here, because what it's saying is for word problems, we're not going to switch the letters around, which I don't really agree with. For the inverse, we're always switching the variables, but it is an important point that they're making here. What I think we want to change this here, not find the inverse, but we want to solve for r. is really what they're trying to get you to do here. Get r by itself, which is fine, kind of the same idea, what we're looking for in the inverse. So d equals r squared over 24. We're going to times both sides by 24 to get r squared, and then we'll square root both sides to get the square root of 24. D equals r, and that is really helpful if we want to figure out the speed r if we know d, because now we can just put 114 right in there for the distance, right? They're saying estimate the speed if the distance is 114, and now we can go straight to our calculator and plug that in. So 24 times 114, and we'll square root that, raise it to the 0.5, the 1/2 power, and 52 miles an hour, 52.3 miles an hour is how fast that car must have been going. So use that thinking here on number 5, and when they say find the inverse of this word problem, what you're doing is just getting v by itself. So move this around, get v by itself, and then answer the question that follows. All right, last part here. Let's talk about our inverse functions. If f and f, the inverse of f, are both functions, and if f pairs a with b, then f, the inverse of f, must pair b with a. All right, so what this is saying is if the function and its inverse are both functions, all right, then they're going to cancel each other out if you do both of them. That's what this is saying here, right? One cancels out the other. You get x for both of them, which makes this last problem very easy as long as f is a function, right? And this is a to the first power, so this is going to be a straight line, right? And then its inverse is also going to be a function. We'll also have a straight line. These two are going to cancel each other out, so the inverse of the function of 374 is just 374. They cancel each other out. The function of the inverse of negative 99 pi is just negative 99 pi. It's just that straightforward, right? And those are your two answers. So wrap this up really quickly. I think you can do this in about 3 seconds. Tell me the answer for understanding check 6. Wrap this up, and any questions, we'll go over it in class.